This is going to be for this field, the initial field. But remember, this is just a copy. We're not going to use this for actual flanging. Okay. So what you want to do is you want to copy this field. And once you copy it, I would say also before copying, you want to rotate your collimator 90. It's 180. But the thing is, you can't have leaves coming through the middle here, right? So in order for leaves to come in through, your leaves have to come and swoop in. Otherwise, you're only going to have leaves blocking here laterally, and you can't block in here. So you got to rotate your collimator so that the leaves come and swoop in. Okay. So, and as you rotate, of course, you want to make sure that one thing to note also, I think it should say here, that when you are rotating it, it is here somewhere. You want to say no. When it says rotate with collimator, you want to say no. It's defaulted at yes. The reason why we want to say no is because if you notice these blocks that are here, so this position drew these blocks. If you said yes, rotate with collimator yes, these blocks would rotate along with it. So they would be rotated 90 degrees. But we want to say no. So in this plan, I would say no, and then I would copy, or I would rotate the collimator, excuse me. Rotate collimator, I would say no, and then once you do, you should be able to, for the most part, have the blocks correctly. One of the things that might be incorrect is your X and Y values. And I'll show you what I mean. We can do one real quick. All right, so I said no. Oh, I can't rotate yet because I need to copy. So let me copy the beam. Okay. So this is just kind of give you an idea of what I'm kind of talking about. If I rotate it 90 degrees, you notice how the field changes because it rotated 90 degrees. But I still have the same blocking pattern. The thing is, you just need to make sure that you match, the same X, Y values to this field. Does that make sense? So one of the easiest ways maybe to write down on a sheet of paper, what these values were previously, and then from here, after you rotate the collimator, just kind of write down the correct geometry, right? And if it doesn't make sense, I'll go over with you when you get to that part. If it doesn't make sense right now. Okay. So we've got our sidewall hooks, right? Let's say we correctly already rotated it. We've already added our MLCs. You'll copy and oppose after you're done. So that gives you your PA sidewall hooks. You're going to want to create two calc points, one for the right and one for the left. So you're going to create two calc points at midplane. You're going to rotate your collimator at 90 degrees. And you'll just basically create sort of an optimally weighted plan, APPA. And for your prescription, you'll just use the right calc point for your dosal calculation, for your sidewall hooks. At the same time, you're also going to change your whole pelvis to 0. Because remember, in our first trial, it was 180 times 25. In our second trial, you're going to change that to 0. Because we're only concerned right now with the sine mode boost. This is the only trial that we're working on for trial 2, it's just the sine mode boost. So the sine mode boost is treating both left and the right sine mode boost. Okay. So I'm going to prescribe 0 dose to the whole pelvis. Don't delete the themes from trial 1. You'll need those for the composite. You'll evaluate the plan, and then there's questions towards the end that are for your report. All right, so that's trial 2. Questions on